The next question, look at this. It's also a spiral compound, but the difference is this. Look at the board. You can look at the board. I've also drawn it on the board. So look at the board. At this point, let us use the same principle. Let's get the number of sides. This one is having 1, 2, 3, 4, right? 4 plus this 5, right? So this one 1, 2, 3, 4 plus this 5, right? All right. So that means both of them are having 5 sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Both of them are having 5 sides. However, where both of them are having like if I exclude the point of attachment, they are both having 4 atoms, 4 sides. So if you want to name now, if you want to number, you start your numbering from this side. Do you know why? Because of these substituents. So point of attraction or attention will be given to this one because it's having a substituent. So your numbering will start from here. So you'll be having 1, 2, 3, 4. Do you understand? So the reason why I'm starting numbering from this other side, they're having both numbers of sides. Do you understand? Excluding the point of attraction you grab. So the reason I'm starting is because A is carrying substituent. If you look at this one, I started from any side here. Why? Because they're having the same number of atoms outside the point of attachment, and that means I can start from any of them. But for this one now, I'm starting with this because of what this substituent that is having. So let us name. So the first thing you should ask yourself is what organic compound is this? What organic family is having triple bond? This is triple bond and single bond. And I told you earlier in my video that when you have triple bond and a single bond, I told you that triple bond will take over. The organic family name will become triple bond. And which organic family has triple bond? Alkyne, right? All right. So how many carbon do you have here in the parent chain? They are just 2. All right. They are just having 2. So that means you're having earth, right? Then one of them is having a cyclic substituent, right? It's having a cyclic substituent. In this case, if you see, don't be confused or don't be quick to say, oh, why can't the cyclic substituent be the parent chain? No, do you know why? It's all of them are single bond. One wants to single bond, so it's still single bond all through. So and when single bond and triple bond are in a compound, I told you the triple bond what takes over. So alkyne is the organic family. Why the cyclic? Because all of them is just one wants to automatically becomes substituent. So now if you want to number, the issue will now be where decide to start numbering from. So in this case, you can't start numbering from the right because the carbon on the right hand side does not have any substituent, right? It's only having nitrogen. But the carbon on the left hand side is having substituent. So that is why automatically I'm going to start numbering from the left hand side because the carbon on that left hand side is one carrying the substituent. So in this case now, you go for the functional group first, then you still consider the carbon that is carrying what substituent. All right, when you want to number, you start from OH, which is 1, 2, 3. Now, between here and here, you should know that it is 2 carbons that can carry double bond and triple bond. I told you before, it is 2 carbons that can carry double bond and triple bond. So automatically, you should know that there is a carbon here which is 4, there's a carbon here which is 5. Do you understand that? So I don't want you to get misled by saying that from this part, this is the last carbon. No. So because it is triple bond, do you understand? Automatically, the examiner wants to trick you if you truly know that it is 2 carbons that can carry single bond and double bond. So here now, 4 and 5. So carbon 4 and 5 is the one carrying this triple bond. So if you go by this, so this will be the parent chain is 5. So they have pent. Now, for functional group isomerism, the organic compounds must have the same molecular formula. Please let me reiterate. For functional group isomerism, the organic compound will have the same molecular formula. So basically, it involves 2 or more compounds, but basically or commonly it always involves 2 compounds. So these 2 compounds will have the same molecular formula, but they are going to have different functional groups. Both of them will have the same molecular formula, but if you look into their structure very well, you will find out that they have different functional groups. Look at the board once again, C4H80. Now from here, I could predict that there is aldehyde here and there's ketone here. How do I know? Let me C4. That means let me write C4 for aldehyde. bonding with alkane, that is butanol, right? Let me write the structure of butanol on the board. You see. Please count the numbers of carbons you have there. 1, 2, 3, 4, right? Justifying this, right? Count the numbers of hydrogen you have there. This is 3, 5, 6, right? This is 3, 5, 7, 8, right? 3, 5, 7, 8. Justifies this 8 hydrogen I'm having there, right? You could see oxygen here. Justifies this oxygen. That means this compound, this molecular compound, I can have this structure from this molecular compound. This organic compound, I can have this compound from it. Let me now write for ketone. See, how many carbons do you have here? 4. 1, 2, 3, 4, right? How many hydrogen? This is 3, this is 5, right? 5 plus 3, this is what? This is 8. So you could see that from this molecular formula, I can bring out 2 structures there. 2 different structures, and these 2 different structures indicate 2 different organic families. Do you understand what I'm saying? From this molecular formula that I have here, C4H8O, I can, if I write the structure of this C4H8O, I can bring out 2 different organic compounds with 2 different functional groups. Do you understand? So when you have a molecular formula of 2 compounds, whereas when you rearrange them, when you write the structure, you'll be having 2 different functional groups or 2 different organic family. You say that kind of isomerism is functional group isomerism. So which of them is most volatile compound? It will be the least, right? The one that is having the highest degree of branching there. It can be N-pentane because we are seeing butane there. Do you understand? And we are still seeing propane there. So based on the degree of branching, the one that has a lot of substituents in it here is what? All right. So this question is testing you on the chemical properties or reactions. When you hear chemical properties in chemistry, it simply means the reactions that a compound can undergo or an element can undergo. So here now, when I say chemical properties of alkene, it simply means the reactions that alkenes can undergo. So because it's CBT-CBE, expect questions like this. Do you understand? Expect questions like this. You'll be asked to predict the product. Do you understand? All right. So here now, you should know that this is dehydrohalogenation. That means that, please look at the board. Let me state this fact. For double, when you remove a single bond from an alkane, it becomes double bond. That site, double bond will be formed at that site. When you remove a molecule from alkanes, what will be formed at that site? Double bond. When you add the molecule across double bond or triple bond, it will end up forming what? Single bond. With this, you can go on. So, all right, please look into the slide. Here now, I'll just tell you what to do. You are removing the molecule. sp hybridization is found in the right answer is C, alkyne. Alkyne has sp hybridization. Alkyne has sp hybridization. Alkane has sp3, while alkene has sp2, while alkyne that we are on has sp. Do you know what it means? It means one of s orbital. So that is why if alkene wants to react, it's going to use this free orbital. And for alkane, all of them are locked. So that is why they are single bond. Unstatical reactions involve dash. So this is part of the reactions that alloalkane undergo. Unstatical reactions. So what it means is A, the right answer is A. That is silver salt of carboxylic acid in tetrachloromethane. Do you understand? So that is the reaction. That is what the reaction is all about. Silver salt of carboxylic acid, when you dissolve it in what is it called, tetrachloromethane, you can form alloalkane. Basically, it is done with bromine and chlorine, but it is common with bromine. Do you understand that? So alkyl halide will be formed. Also, silver halide will be formed, and then carbon dioxide will also be formed. So when primary alcohol oxidizes, that is when the hydrogen which makes up the functional group is being lost. Am I communicating? Double bond will be formed at that carbon that is carrying the oxygen. Are you with me? And if it is primary, aldehyde will be formed. But if it is secondary, for example, look at this. This is a secondary alcohol. Why? Because the carbon carrying the OH is only attached to one hydrogen, unlike this one. Am I communicating? All right. So here now, if you bring in oxygen, so the oxidation in this case is that this hydrogen will be lost. Am I making sense? This hydrogen here will be lost. So you'll be having CH3, C double bond. Am I making sense? Then you have this CH3 can still be here. Am I making sense? You can also put it anywhere you want to put it. So you can still put it like this. So you can see this secondary alcohol. So when this reaction happens, what happens? You see a ketone will be formed. So this one clearly, explains that ketone will be formed. Ketone is that carbon double bonded to hydrogen is separated by alkyl group. Am I making sense? So when secondary alcohol undergoes oxidation in this case is that the oxygen will make hydrogen here to be lost and double bond will be formed here. That is why it is oxidation. Am I making sense? All right. So then if it is secondary alcohol, you have ketone being formed. Am I making sense? So and if it is primary alcohol like what we have here, you have aldehyde being formed. So that is just the principle. All right. When you have this, you are asked to predict the product, right? All right. So the first thing is, what compound is this? This is propantoone, which I told you that is also known as what? Acetone, right? Now, this H you are seeing there is saying that it's undergoing reduction reaction. So the reduction reaction can be, how will I put it? Can be initiated using any of the powerful reducing agent. And I told you the powerful one we use most in organic chemistry is lithium aluminum hydride, like the one I've given you before. So here now, what it says is that hydrogen is coming in and then the double bond will be broken. So what will you have here? You have what? Propan2-ol. Do you understand? You have what? Propan2-ol. Hydrogen goes to meet the oxygen, right? And the double bond is being broken. By now, we should know that an element cannot exist without having an atom in it. Am I communicating? And the three particles in an atom is the proton, the neutron, and the electron. Are you with me? So back to what I'm explaining. So for screening effect, what it talks about is reaction between two shells. And what is the reaction between two shells? That is repulsion. Am I communicating? And what nuclear chart talks about is force of attraction between the nucleus. And what is causing the force of attraction in the nucleus is the proton. So the force of attraction between the proton and the what? And the outermost shell electron is what nuclear chart talks about. Am I communicating? All right. So how big an element will be, or how small an element will be dependent on the one that is playing the highest role. Let's put it like that. Or the one that is more prominent. Am I communicating? So if screening effect is more prominent, do you agree with me that the size of the atom will be bigger? Do you know why? Because if this shell is repelling this shell, what will happen? There will be expand, right? There will be expand. So that means if screening effect is prominent in an atom, am I communicating? So what happens is that the size will increase. Why if the nuclear charge is prominent? What will happen? There will be an attraction between the center and the what? And the outermost shell electron. So what will happen? There will be constriction. This is times 10 to the power minus 34 joule second. Why this one times 10 to the power 8 meter per second. All right. So please, the question A says we should what? Please look into the slide. All right. It says the question says we should find how much energy is emitted, right, when it generates a photon, right? All right. So we are looking for the energy. So please look at the board again. You have the Planck's constant, you have this, and then our lambda is 589. The lambda is in nanometer, so you convert it to meter. So that will be times 10 to the power minus 9 meter. There's a question in your textbook. There's a question in your textbook that talks about you getting frequency of visible region between 400 and 100 nanometer. I'm going to give you this as an assignment, but I'll just guide you on how to do it. We are still going to use this formula, which is V equals to F lambda. Am I communicating? So use the speed of light. You get the frequency. You also get the frequency at 700. The difference is just that here now, you substitute this for this, you get the answer. Am I communicating? All right. So for you to know that I've actually gone through your textbook and have also made other researches just for you to have beautiful A's in your text and exam.